And I wish in this short time we are going to discuss something which is very important, not from ENT point of view, but all our general concepts regarding the physiology, because balance is something which needs a lot of attention. And you know, it's not only ENT which is concerned with the pathologies related to balance, but there are many other specialties who look after these patients. So, do we ever wonder how we keep our feet firm when we go downslope, and similarly how we keep our feet firm when we are going up? So this is all happening in our daily life, but we never know how many mechanisms are involved to maintain this balance. So again here, this you must be remembering, in our childhood everybody has done this, and similarly there are many road travelers who keep their balance, maintain their balance in a very nice way. Similarly, those who have experienced the roller coasters abroad or in Pakistan, they know how fast they are moving, they are shouting, they are crying, but still maintaining their balance in a very nice way. So, do we really wonder how we do this? Once we are shaken, rotated rapidly, how we maintain our balance, and similarly when we go downhill or upstairs, how we maintain our balance. Then obviously you have an inherent curiosity to know about the how we maintain our balance, posture, and body gait through different mechanisms. So today's topic was to discuss with you people or share with you people how we maintain it. Why this is important? Because if we know the physiology, then only we will be able to talk about pathologies. So these are very basic things, and I hope you will at least remember some part of it while applying your knowledge to the patients. So we know we have got semicircular canals, we have got utricle, and we have got saccule. We will discuss this all shortly. So there are many functions and assignments which are related to these organs, and this is the subjective sensation of motion and spatial orientation. What do we mean by spatial orientation? That is the location and dimension of objects with reference to space, and how different objects are related to each other, and how we visualize it, and how we manipulate these objects at the brain level. So this is known as a spatial orientation. Then how these structures lead to muscle activity when we want to maintain our upright posture. So this is how we then it's not only the muscles, but important organ to maintain the balance is the eye also. So we have to stabilize the eye. These are mechanoreceptors, and we know what do we mean by mechanoreceptors. You are looking at this, and how they are uh, related to each other. So two vectors that are perpendicular to each other, where the two things vary from each other independently. This is known as vector. So semicircular canals are so arranged that they are in specific planes. So they are orthogonal to each other. So here you can see the different arrangements of these semicircular canals. So shortly we will be discussing what are those basic structures which are involved, which are present in the internal ear and are concerned with the body gait, equilibrium and posture. So three semicircular canals uh, which are responsible for sensing the angular acceleration. And these three semicircular canals have got one ampulated end and one non-ampulated end. And here you can see it has got an ampulated end and the other end is non-ampulated. So one ampulated end and the other one is non-ampulated. So in each ampulla we have got the sensory structure which is known as crista. And the crista, the hair of the vestibular cells are present. And we will see some pictorials in the next slides. So as I said, they are placed in a specific orientation. So here you can see this is known as a rule of the right hand. You can appreciate how these are related to each other as it is actually here. Then why these three semicircular canals are placed like this? So it has got a logic, it has got a reason, and that is the reason that we have got different axes of movement. So these are the three axes which are described, which are known as roll, yaw, and pitch. This is taken from the navigation protocols. So here you can see this is how the yaw is, this is how the roll is, and this is how this is the roll, and this towards this side is the pitch. So these are the three actually movements which are responsible for it. Now we will see here what happens. Now please concentrate. Every semicircular canal has got a liquid or a fluid which is known as an endolymph. And with each movement, we appreciate that when the movement is like this, the fluid movement will be in that specific plane. Similarly, when the movement will be like this, nodding movement, then the fluid will be moving in different canal in a different specific way. Similarly, the third movement, you see when the it is in this plane, it will be moving in a different way. Okay. So basically, we have got a movement which is like this. We have got a movement like this, and then we have got a rotational one. So as I said, in the ampulated end, we have got the sensory structure responsible for initiation of the nerve impulses. So this is known as a structure. We see here like this and isolated over here like this. So it has got a cupula and it has got a basement which is all put together is known as crista ampullaris. This is a structure which will move with the movement of the fluid. Here again, when we are static, it is like this. Once we start moving in different directions, it will move in both directions. During movement, there is another concept that is inertia, because the fluid is contained inside a bony canal, and bony canal inside we have got a membranous canal. So when the bone moves, there is some lag or some gap before the endolymph moves little after that. This is known as inertia. So we will tell you how this happens. So this is the concept of inertia. If the solid bottle is moving, the liquid is moving little later, and it continues moving even the head is stopped. This is the concept of inertia, which is over here. So again, sometimes the axes are x, y, and z. Some people describe it in different way. So you can see here the x, y, and z axis. So these are the three axes. It's the neural input. The more it is, more will be the response. It's directly proportional to the angular velocity. Now, what happened at the cellular level? What will be responsible for the initiation? This is known as transduction. So, excitation and inhibition. We have got two structures over here, which one which is the taller one, this is known as kinocilium, and the smaller ones are known as stereocilium. So the movement towards the kinocilium and movements away from the kinocilium, this is the basic physiology which will further initiate what's going to happen. So here we will try to explain that. So look at this is what is the crista ampullaris. So with this movement, the vestibular activity will be more in one direction and it will be inhibited in another direction. So this movement is responsible for initiation or inhibition of the nerve impulses. Those who are in ENT over here, they know that we have got an nystagmus, and that nystagmus has got different degrees, and that is the contribution is from Ebert's. There are Ebert laws also. So you can see the diagram below that it is the push-pull arrangement. One is pushing and one is pulling. So this is the same arrangements we have got in semicircular canal. So if one canal is moving in one direction, the other is in the another direction. So this is the arrangement which gives it a balance. So once any of this arrangement is deranged, the balance will be upset and patient will have symptoms. After semicircular canal, we have got saccule and utricle. These are two another structures, sac-like. It's like a sac, and it is placed over here. So these blue ones are semicircular canals. These two structures are utricle and saccule. The semicircular canals are opening into this, and then we have got another sac which is saccule. They have different responsibilities now. As we have got a cupula or crista ampullaris in semicircular canals, here we have got a macula, which is the sensory structure. This is responsible for two things: horizontal linear force and the vertical linear force. So now their function is different from the semicircular canals. Macula, if you remember, we have got an eye also. So function of the otolith organs, we will have a nice clip over here. Now look at how the utricle and saccule are placed and how they work. So look at this beautiful diagram and picture. So this is a hair cell. These are the kinocilium and stereocilia, and nature has put over it the calcium carbonate crystals. So this is again responsible for giving pressure and the bending and shearing forces over it. So If this will move towards the kinocilium, obviously initiation of impulses will start. This is an electron microscope picture of how they are placed. You can see the calcium carbonate crystals, and we have seen the kinocilium and stereocilia. It's an amazing arrangement nature has made. Here again you will appreciate that how they work. Now you see if it goes towards the kinocilium, the initiation will start and you will see the impulses moving. If it goes away from the kinocilium, then there is no nerve impulses. So this is the vestibular activity which start like this. You see towards the kinocilium, lot of action potentials are generated, and if it goes away from it, then it is inhibited. Now it is the and you see now it's the least action potential away from the kinocilium. So this is the basic physiology which is responsible for maintaining the balance. Then obviously this from the macula, from the cupula, these nerve impulses are generated, and these nerve impulses now has to go to the higher centers. So we have got vestibular nuclei, before that we have got vestibular ganglions, then there is reticular formation, and then is the thalamus, and ultimately it reaches to the higher centers in the gray matter and the brain. In addition to semicircular canals itself and the saccule and utricle, we have got three important reflexes which are responsible for maintaining body gait, equilibrium, and posture. These are known as vestibulo-ocular reflex, vestibulo-colic, and vestibulospinal. The most important one, which we can easily test, is the vestibulo-ocular reflex. You see, when we run fast, so our whole body is moving. Our skull is also shaking rapidly. For example, in the marathons or other races, 100-meter races, the people run and they are shaken very vigorously, but still they maintain their balance because the eyes are participating in maintaining this balance. So this is known as vestibulo-ocular reflex, and we will see how it happens. So look at this diagram. So if one side is excited, the other side is inhibited. So these are the extraocular movement which gets its connection through the vestibular system also, and they put together maintain our eyes and gaze stability once we are walking or running. So to test this vestibular ocular reflexes, we have got a test which is known as head impulse test or thrust test. So this is how it is done, and we will see the normal person will maintain the eye, but if it is abnormal, there's brainstem lesions, then they won't be able to fix the eye. So this is vestibulo-ocular reflex. Then is vestibulo-colic. This is for the neck muscles. And then we have got vestibulospinal reflex, because spine has to be fixed once we are in an awkward position, as is seen in these pictures. So with reference to gravity, we have to stabilize our muscles which play an important role in maintaining the erect posture of the body. Then our postural reflexes, these are three important reflexes. To conclude, it's not only the vestibular system, there are two other systems which play important part in maintaining our body gait and equilibrium and balance. Please remember vertigo and dizziness is a very awesome and horrible experience to those who have experienced it. And there is hardly anybody who has not uh, ever get vertigo or dizziness. There is some sort of vertigo or dizziness. It's a very extremely common condition or symptom. So if we are feeling dizzy or we are having a patient with vertigo, it is always difficult to assess these patients because it is not only one system, there are multiple systems working at the same time. So this is how to conclude it, that it is not only the vestibular system which is responsible for equilibrium, rotation, linear movement through the saccule and utricle and semicircular canals, and it is also the visual input which is important. And it also tells us, because once we close our eyes we won't be able to maintain our balance while walking. The third thing is the inputs which are coming from our joints, muscles, tendons. They also tell us the position we have in space, how we are sitting, where we are sitting, and these all inputs are coming from the proprioception. So proprioception, visual and vestibular put together, they ultimately reach to an integrated center, and that is the center over here. It is the cerebellum which goes behind, and it is the cerebral cortex which is like this, and then ultimately brainstem, thalamus, and all these. And how we maintain it then, these are the inputs, this is the integration, and finally how we maintain it through these things. So, and ultimately we are feeling balanced. Maruk, ऐसे बड़ा टाइम क्या है? हाँ